All right, welcome back to another Python tutorial. Today we're going to talk about the logic behind selection structures and how to use them in pseudocode. So first things first, we want to talk about our relational operators. Our relational operators are fairly straightforward and simple. We have a few. We have a greater than, a less than, greater than or equal to, less than or equal tos, and not equal tos. All of these are judging whether or not the statement around it is true or false. So I might be able to say something like x is greater than y, and as long as the value of x is in fact greater than y, it would evaluate to true. If it wasn't, it would evaluate to false. Same thing goes with the rest of them, less than, greater or equal to, less than or equal to. We'll use the equality operator. Notice it's two equal signs and not one equal sign. It's important that anytime you're checking a condition, you throw in those two equal signs. Because the single equal sign is an assignment operator, it does something different. It takes what's on the right and assigns it to the namespace in memory on its left. And the double equal sign will check a condition to see if what's on the left and right hand side are the same, and as long as they are, it will return true. If they're not, it will return false. The not equals is the exact opposite. If as long as they are different on left and right side, it will return true. If they are the same on the left hand side, it will return false. So then getting into our structures here, we have a few different structures. We have what we call a single alternative structure, or what I like to call a one-way selection. So this is basically kind of a detour in the road. What it does is it allows you to just take a slightly different path and then come right back into the mainline logic. So essentially what we're going to want to do is make sure that we are going to do something extra when the condition is true. For the sake of not typing everything out, I'm just going to do a bunch of copy paste and we will talk it out. So here's our first example. Let's say you are in business and you're working off commission, and if you make a certain sales figure for the given month, then you earn some sort of a bonus and your commission also increases. So here's what that might look like. Say if you have a variable called sales, it comes in via input or pulled from some sort of file or database. You could say something like this: if the sales is greater than 50,000, then, and notice the indented statements, those are the things that are going to happen if this condition is true. So if that sales value is actually greater than 50,000, we can set the bonus to 1,000, increase our commission rate by 2%, and we can display you met your quota. Then we have that end if that just kind of shows that we're done with the selection structure. Now, I personally don't mind if you leave that end if part off, as long as your indentation is done well and correct, because I can tell that the indented blocks, the indented code, is part of that block of code set by the condition, and that's pretty important. Okay, but that's a one-way selection structure. There would be some code above, there would be some code below, some logic above, some logic below. But essentially what this is a detour. It is a way to do something if this is true, and if it's not, we just continue on by like it never happened. Okay. The dual alternative structure is a little bit different. The dual alternative structure forces you to pick a path one way or another. So I think about this, instead of a detour, it's a fork in the road. You have to go right or you have to go left. You can't choose both paths, but you must choose one. You have to go one direction, okay? Usually there's two paths and that's it. So in this particular example, what I'd like to show you is maybe you are taking the SAT and you're trying to get into a certain college. Well, they're only going to accept you if you hit a certain value on your SAT, and if you don't, they're going to deny you, or at least put you on a wait list. So here, let's say you have an SAT score that's coming in via input or database or file or wherever it may be, but you have an SAT score coming in, and if it's greater than 1100, then it'll display that you've been accepted. Otherwise, now we have this keyword else. Notice with the keyword else, there is no condition. We do not need a condition because the else block will only execute if the condition in the if statement happened to be false. So here, the else is display you've been put on our wait list, and display you can retake or submit another SAT score. So the trick here with the dual alternative is it is a fork on the road. You have to pick one path or the other, but you can't choose both. There is no way to display both you've been accepted and display you've been on our wait list at the same time. It'll never happen, and it's absolutely impossible. You can either display that you've been accepted, or you will display that you've been put on the wait list. And it all depends on whether or not that SAT score makes that condition true or false. If it's true, you're accepted. If it's false, you're not. Some structures just aren't as easy to answer with a simple question, a yes, no, or have only two paths. So here's what we call a nested structure, where you have two or more possible unrelated restrictions that may need to be made. So maybe you've got one decision that has to get made, and then once you make that decision, you can ask another question, something that's somewhat related but completely different, a different question altogether. So this is where you might nest these structures and put them together. So in our case, let's say you're applying for some sort of loan, and the qualifications for this loan are fairly simple. In order to get the loan, you have to be employed for at least a year with your current employer, and you need to make at least $50,000 a year in order to get this loan. Maybe you're applying for a mortgage on your house, whatever it is. So we might do something like this. We'll ask to see if your salary is above 50 grand. And if it is, and that's true, we may ask another question. We'll see if your year's worked is greater than 1. As long as both those conditions are true, if you got in and said it was true to $50,000 in your salary and your year's worked is greater than 1, we're going to display that you qualified for the loan. Now, if your salary was greater than $50,000 but you weren't working with the company for at least a year, it'll display you must be with your current employer for at least 1 year. Now, there's also this else down here that says you must earn at least $50,000 per year to qualify. That else only runs if this initial if didn't come out true. So you can kind of see how the indentation all lines things up. This if statement is nicely aligned with this else statement, so I can tell that this if statement correlates to this else down here. If this comes out true, then I can enter the block of code that it makes. However, if it comes out false, I can jump from the if down to the else that it matches with on the indentation and find out what I need to do. In our case, make $50,000 a year. If the salary is true, I can ask the next question, and then you can see the new sets of blocks of code, the new set of indentation, and how this else lines up very, very nicely with that if. Okay? And again, this is still a fork in the road. We have to pick a path, except we're coming to a fork in the road that leads to another possible fork in the road. So we have different paths that we can pick, and we can continue branching off and hitting these forks, as many as we may need for whatever the program is that you're trying to discuss. Now, there is another nested example that I want to give, but it's not a very good one, but I want to show it to you anyways. And this is exactly what I would call a bad example. This example I don't think is particularly well written, simply because they are not unrelated questions. It's a question that all relates to the same data. In our case, it's grades. So we're talking about a score that you're given on, say, a test or a quiz or assignment or for a final exam or whatever it may be. And what we're trying to do is produce the letter grade associated with it. I could easily say something like this. If the score is greater than 90, we're going to display an A. And if it's true, I'm going to skip this else, and since all of this stuff is in the else, I'm going to skip all of it consequently. Now, however, if my score is not greater than 90, then I have to jump into the else block and ask more questions. The score is greater than 80, display a B, and if it's true, we skip everything in this else, okay? And it continues to move on from there. These nested sections are just more questions to ask to dive deeper and deeper in when we answer false or no to one of the preceding questions. Now you can see how this gets to be kind of a mess and things start to scaffold to the right very, very quickly. And there are better ways to do this type of problem. So instead of nesting it, which can be done, it does get ugly. The better alternative is use something called an else-if statement. So it allows us to ask more if questions when something's false, but to do it in a much more streamlined way. So I'm going to display basically the same program using a slightly different structure called the else-if structure. It replaces the nesting conditions for conditions that are on the same value. This looks a lot neater. It does the exact same thing. If my score is greater than 90, then display an A. And if that's true, we skip everything that has the keyword else associated with, just like we did before. But many of these other keywords also have an if correlated to it. So if this happens to be false, then we can come down to this else, run it, and check another condition. So it just kind of combines this statement up here with this one down here. It basically takes this and throws it up on line 41, which you can see. So it just kind of bridges the gap and kind of brings it all back together nice and tight. So it's a much easier to code, it's a much easier to read, and consequently easier to understand. The trick, though, is you have to make sure you write things in a particular order. You're not going to be able to jump from score is 90 down to score is 70 and assume that a score of 88 is going to produce a B. Because as soon as one of these is true, it does the indented block and skips all the remaining else's throughout the coded structure. So If the score is greater than 90, print an A. Otherwise, if it's greater than 80, print a B. Otherwise, if it's greater than 70, print a C, and so on and so forth, down to the final else again, which does not have a condition. That will run if none of these came out true. Right? That's kind of the trick. But you could never ever do something like this and throw an 80 here and a 70 here. And if you don't already see the mistake, just think about a score of an 85. It should produce a B, right? 85 is not greater than 90, but 85 is greater than 70, so it will display, say, a C, if I were to switch these, okay? And not the B appropriately the way that we would want it to, right? And that's sort of the issue that we would have here. And then this would get skipped and it wouldn't quite work. So we want to make sure that we keep these in an organized manner as best we can. Same as we would have had up here, but we need to make sure that we are very careful with this. There's no reason you can't do it backwards from 60 on back up to 90, but you just need to keep yourself organized. The last thing that we want to kind of share in this video are what we call logical operators, the and, or, and not operators. Okay? These allow you to kind of combine conditional statements into one single condition. So things that may not be related, okay, like we were in the salary problem, but to make them so that you can make it a little bit more compact and easy. So let's go back to that salary problem for a sec. Let's give ourselves some more room here. And let's go back to that loan. We can say something like this: if our salary is greater than $50,000 and years worked is greater than 1, then display we're approved the loan. Otherwise, we display we're not approved the loan. As long as we're not worried about why we're not approved, we can do something very easily with this. The and operator is a Boolean operator. It will allow us to return true only if both the Boolean condition on the left and on the right are both true. That's the trick. The only way to get this overall expression to be true is when the operation on the left and the operation on the right of the and keyword are both true. If either one of those come out false, the overall expression is false. So had my salary not been $50,000, I would not be approved this loan, even if my years worked was greater than 1. Likewise, if my years worked was less than 1, but I was making, say, $60,000 in that year, then I still would not be approved that loan because both of these things would not be true. And of course, if they both come out false, then the overall is false as well. Okay. The other side of that is using something like an or keyword. So let's say our loan was a little bit more lax and I only needed to make $50,000 a year, prove that I'm doing that, or make sure that I'm working at least 1 year. We can take it and change the keyword to an or statement, and what that does is it forces us to return true on the overall expression as long as one or the other is true. They could both be true, but they don't have to. Okay? As long as they're not both false, the overall expression is true. So as long as I'm making $50,000 a year, I can be approved. If I've been working at my place for over a year, I'm approved. It doesn't matter that I have both of these things. I can, but I don't need them. I just need this or this to be true for the overall to be true. If I'm not making 50 a year and if I'm not there a full year, then I would finally just say that I'm not approved of the loan because both expressions would have been false and the overall expression would have been false. Okay? The last logical operator we want to kind of go over is the not operator. This is a really effective one when you're working with Boolean variables. Now, a Boolean variable is just a variable that holds either a true or false. I use this a lot when I'm building some sort of a game or something like that, where I have lots of reasons why I might end the game, and it's a little bit more difficult to write just a huge long condition to check for all of those reasons. So somewhere within my activity, I might have small conditions to check and check that will make the game become a game over state. And so what I'll do is I will create a variable called game over, and maybe I'll set it to false when the game begins. Because I don't want the game to be over, I want the game to be on. And as long as my game is not over, so if not game over, I'll take that next turn. And somewhere in the program I might have more conditions that'll judge whether or not the game should be over. And if it's true, then I'll switch the game over variable to true. And something that's not true makes false, which means I wouldn't take the next term because then the overall expression here would be false. So really the not operator just negates whatever is there. Something that was true becomes false, something that was false becomes true, and this is the context that I like to use those not operators in most often when I'm doing something bulky, something large, something confusing, and I want to simplify the process as best I can, so I make some sort of variable up to help myself out with that process, and I use these not operators appropriately. So there are lots of uses for them. You will find lots of uses for them in this class and in others, but just keep them available to you along with those Boolean variables to make your programs easier to write. Okay? So that kind of does it for the conditional statements. They're sort of the pseudocode. We'll get into some of the flow charting for that in the next video. We won't go through every single condition here, but I'll show you how I like to set up the flow charts and keep things nice and aligned and centered so that your flow charts are neat and not going and spidering out in all sorts of different directions. So we'll see you in the next tutorial.